sklearndatasetsfetch20 newsgroups. Description: this function fetches the 20 newsgroups dataset, a collection of approximately 20,000 newsgroup documents partitioned across 20 different newsgroups. It is a widely used dataset for text classification and natural language processing tasks. Inputs: data home, the directory where the dataset is stored. If none, it will be stored in the scikit-learn data directory. Subset selects a subset of the dataset. The options are train, test, all. Categories: a list of newsgroups to include in the dataset. If none, all newsgroups are included. Shuffle: whether to shuffle the dataset. Random state controls the shuffling process if shuffle is true. Remove: a list of strings to remove from the dataset. Download if missing if false. Raise a I/O error if the data is not locally available instead of trying to download the data from the source site. Create directory if true. Create the directory data home if it doesn't exist. Transform: whether to use a simple preprocessing transform that removes punctuation, converts to lowercase, and applies stop word removal. Outputs: dataset: a dictionary-like object containing the following keys. Data: an array of strings containing the text documents. Target: an array of integers representing the target labels for each document. Target names: a list of the names of the target categories. DESCR: a string describing the dataset. File names: an array of strings containing the file names of the documents. Steps: downloads the 20 newsgroups dataset from the source site if it is not available locally. Extracts the relevant data based on the input parameters. Preprocesses the data if the transform parameter is set to true. Metrics: accuracy: a measure of the percentage of correctly classified documents. Precision: a measure of the percentage of correctly predicted positive cases out of all positive predictions. Recall: a measure of the percentage of correctly predicted positive cases out of all actual positive cases. F1 score: a harmonic mean of precision and recall. Visualization plots. Confusion matrix: a visual representation of the classification performance, showing the number of correctly and incorrectly classified documents for each class. Word cloud: a visual representation of the most frequently occurring words in the dataset. Fine-tune parameters. Categories: the choice of categories significantly affects the model performance. Selecting categories with distinct topics can lead to better accuracy. Transform: using preprocessing techniques such as stop word removal and stemming can improve model performance by removing irrelevant words and reducing the dimensionality of the data. Uncertainty methods. Bayesian methods: these methods can estimate the uncertainty in model predictions by considering the distribution of possible model parameters. Ensemble methods: these methods combine multiple models to improve prediction accuracy and provide an indication of uncertainty by measuring the disagreement among models. Challenges and fixes. Challenge 1: the dataset contains a large amount of noise, including irrelevant words, misspellings, and slang. Sample use case that resulted in challenge 1: a model trained on the raw dataset might learn to associate certain irrelevant words with specific categories, leading to poor performance on unseen data. Fixes to challenge 1. Preprocessing techniques such as stop word removal, stemming, and lemmatization can reduce noise and improve model performance. Using a robust classification algorithm that is less sensitive to noise, such as support vector machines or naive Bayes. Challenge 2: the dataset is imbalanced, with some categories having significantly more documents than others. Sample use case that resulted in challenge 2: a model trained on the imbalanced dataset might be biased towards the majority classes. leading to poor performance on minority classes. Fixes to challenge 2. Using data augmentation techniques to increase the number of documents in minority classes. Using a classification algorithm that is designed to handle imbalanced datasets, such as random forest or XGBoost. Adjusting the class weights in the classification algorithm to give more weight to minority classes.